Okay, thank you everybody for coming to this presentation that will be a more secure world for Android apps. A little bit about who I am. My name is Mercedes Wyss. I am coming from Guatemala for speak to this conference. I am community leader in Guatemala. I have two communities. One is Google Technologies focus, Devs Plus 502, and I have a JSON Chapter 2 that are Java communities focusing on increasing women participation in technology. And I was a member to Java Chapter 2. Right now, I am CTO in a startup based in Guatemala that is called Productivity, and I am really a full stack developer. So I make backend, I make frontend, I make mobile apps too. And I am part to do two programs. There is the Auth0 Ambassadors program and the Oracle Groundbreakers Ambassadors. And I have a Duke's Choice Award in Educational Outreach. So we will talk today about aspects of security in Android development. And I will answer before to start the talk one of the most popular questions that people make to me in the talks. And always is what we can do about users make a root in our cell phones. The truth about this is that we can do nothing if people make root over their cell phones and they have access to everything. And people say why we cannot make something like make Apple with a jailbreak that you can run over iPhones, right? But the fact is that Apple is basically owners to this hardware and the operating system. So they indeed, when are provided to the users the fact to make a jailbreak, they are restricted what things they can access after make a jailbreak. In the case of Android, it's an operating system based in Unix, and we cannot restrict to them have access to some things when they make a root over the cell phone. So we will start, and I don't know if you know this company. I will say that yes, right? They have a big issue last year about security, right? When many names and things were exposed, and indeed they receive an injection or a fake information in their system. So this is just one of the many examples that we have right now about how security is important. And this empty room is an example of how developers are taking care about security aspects. So security always is the last thing that people introduce in their systems. And it's the first thing that people are breaking. Another thing that happened this year, for example, was this. This regulation is the responsible that all of us receive insane actualization emails to privacy policies in many companies. So that means that things about crowd-preserved information is being to become more restrictive in the world. So last year was running a lot of surveys about security aspects. And one interesting thing that happened is that people right now is more worried about their private data were stolen in the cloud or in systems that someone entered in their house and stole them there. And it's becoming more and more frequently have cases like Equifax, you know, that people are stealing information. So this talk is, we will talk a little bit of some real cases and other aspects important in Android development. So, but the first thing that I will say is that security is a team effort. It's not something that is just delegated to the people of infrastructure, of the guys that are making our backend, or just in the mobile app. It's an effort that we need to make between all the parts in our system. So I will tell you this case that I call the free hamburgers. Just me, I changed it 10 hamburgers for free for this issue. So what happened is in far lands, in my land, someone create a good restaurant of hamburgers. What happened in Guatemala is that everybody likes eat McDonald's and Burger King. We don't have much gourmet hamburgers. So one guy created a restaurant and was so successful, and they created a loyalty app. A loyalty app is not anymore that we accumulate points, and when we catch 100 points, we can redeem them for a free hamburger. So what could go wrong with that? Well, Depen say, you know, guys, we are losing money with this loyalty program. So what are we doing wrong? We are losing money, but we don't know what we are doing. So think you, what could go wrong, but think in terms of security perspective, because the problem was in the app. So think what could go wrong. Imagine that you are in this meeting of I don't know, chiefs and vice president and say, okay, guys, we are losing money. What the fuck we are doing wrong? And what the fuck we will do for fix that? Yes, all of us have a boss that came to that meeting and say that. And you are this project manager. You don't know what is happening. Well, happened that. Some ones are laughing. The others are not laughing. And this is precisely the problem, Vernon. When I travel, for example, to United States or for Europe, is that everybody's an expert just in one part of all the process. I am just expert on make testing and QA. And I forgot that exists more things. Or I am just the guy that made the designers or implement the user interface. And I forgot what is the other things that happen in our system. And this is why people don't laugh when saw that, because they forgot that exists more than what they do. Happened this. The first thing is that they was creating URIs exposing params. And that combined with use a get HTTP method as protocol for interchange, these params was watched in any way that was monitoring this network. And since they were not using any SSL or TLS certification, this information was not traveling encrypted. So we can guarantee to you that one or a few guys came to this conference with some anthems and were monitoring the Wi-Fi to this place and watched all the endpoints that we consumed during these days. So some people start to do that too in Guatemala and everywhere. And they discover all the URIs that have this hamburger restaurant. So they watched all the codes that they were inserted in the restaurants for accumulate points. So the pattern is that each restaurant have just one code. So they share to all of us the codes, and we can introduce codes in our loyalty application and accumulate points, and they redeem them. So, but they not only expose that, because when we make a login with an email and a password, was shown in the endpoints too. So this is a security problem. So how we can solve this is simple. We need to use a SSL or TLS certification for our information travel encrypted, and we need to use a different HTTP method that like post. So when I use post, this information travel hidden in that when it's in the URI. And we can add to the use of an exchange protocol like JSON or XML. XML is not so good now, but you can use it. So we will have this. And now, with the use of SSL and TLS, this information will travel encrypted. So people can stay monitoring the network, but they will see just this endpoint, but we don't see the information that we are transporting there. So this is a first level of security, right? So other suggestion for this case specific is use health fences. Because in that when we don't have access now to these endpoints, and I know the codes, I can continue accumulating points by free. So we can make to these points only can be accumulated if I am inserting this code in the application when the cell phone is in a health fences around the restaurant. So that means that at least I am in the restaurant or I am next to the restaurant. But that comes to other thing, right? Because for use health fences, I need to have geolocation options and permissions allowed. And that brings to us the part of permission requirement. I don't know if you know, but this changed for Android 6, right? Permission is a way we can guarantee the security of the information to our users. So I am requiring specific permissions in specific situations to our apps. But sometimes people require permissions that the application don't need. For example, if I am just showing picture, why my application need to access to my contacts, to my SMS, or geolocation. So we need to know that. So now was created the part of install time permission. That is how it was working since before Android 6. And now we have the new runtime permissions. Are permissions that we will require to the users when the application is running and in the moment when we need that. And for what is that is because we need to explain to the users why we need these permissions. So this is the install time request that is from Android 5.1.1 and below. and it shows in that way. Is when we install the applications from the Play Store, we show a list to all the permissions that we needed, and this is so simple. The user can accept or not. If they don't accept, we will don't install the application, and if they accept the application, we will install it. But now we have the runtime request permissions that is added since Android 6. Exists a list of all these permissions. So right now, for example, if I need help location, in the first time to my application, we'll use help location. We will show a message to the user for they give us permission for use this help location. They can reject it, by the way, and can say that our application never asks again for this permission. In that, they can come to the application management in the cell phone and restrict permission to our application. So they can enable or disable application as they wanted and only have the perception that we will use that only when they are in the application. So this is how we can manage permission. We define this permission in a manifest file. This is how I can check if I have a permission granted. If I don't have this permission, I need to require to the user. We need to be careful because sometimes that when the user put deny and never ask me again, instead when I put this for ask to them, the application will don't ask for the permission. So we need to guarantee that we have permission before to use some of those functionalities in our application. This is other way how we can request permissions, and this is a cascade of all the things that we can do. And in some cases, they suggest that us to show a message to watch or why we need these permissions. So this is not a talk about the permissions, just is one of the many aspects that we have in security in Android. So this is a link if you want to read more about permission and see the list to new runtime permissions. In that right now are categorized too. And now we will part to other aspect, that is the human verification. Maybe if we have a simple development, we don't know why human verification can be needed, but sometimes our application has components to other application can use it. And we need to guarantee that it's not a bot the one that is using these tools. For example, Facebook that provide to us Federated Identity, the same applications provide to us the fact to use the login, for example. So imagine that we don't want that anyone is stay activating this login part. So we can put a human verification for see that it's a person. So reCAPTCHA is just that, how we watch it in the web. I think that all of us use it. For using Android, it's really simple. We only need to create a site. And when we will define our package name and that we will for Android, and this will provide to us a site key and a secret key, and in that the code that only we need to paste and copy in our application. And we need to add to our dependency, the version 16 for right now, and this is the implementation, and here is when we have a verification to this reCAPTCHA works, and this is a human, and we can do wherever that we need. So this is how we testing. We only put a button or wherever that you needed, and that will run the reCAPTCHA. I put this because I always forgot that when I test, I have an issue, and it's because sometimes I forgot to add my internet permission. So now this is other interesting case that happened in 2014 about Starbucks. I don't know if someone remember that or listening about that. Maybe not. But the news called that convenience over security, because Starbucks says we want to make a friendly application and that have the cost to security. So we will see what happened here. They were storing user data in plain text in the local device. So what that means that anyone have access, with access to the cell phone, to this information, and the information was unencrypted. And what was emails, password, and geolocation information for the users. What happened with the Starbucks app is that they wanted to, the guys, just take the app, open the app, and say, I want to browse this coffee, but never make a login again. This is a permanently open session. So they were selling the emails and the password. So how we can solve this issue in the first level? The first thing is that they was not saving the information in a properly way. For example, in Android, it's really critical because we can have an spyware application that is monitoring all the files that I have in my system and have access to these files. But I can save information in private ways and in ways that only my application will have access to it. So we can use the shared preferences or internal storage. So if I am using shared preferences, this is a way to use the shared preferences. And I think that the issue, if I am not saving shared preference only with my application access, is because I just make copy-paste for tutorials. So I need to restrict access only to my app. This is really simple, but it's a common mistake. The other thing is use the internal storage. I can create files that only will have access my application to read them, not anyone with access to the cell phone. And I can use this other way too, that is, I will put in a private mode. So the next thing that I can do is not only save the information in ways that only my application have access to them. I need to encrypt that information too. So Android, since the API, Android 4.3.3, that is the API 18, is based on the Java cryptography architecture, so I can make encryption using it. And well, we have the Android key storage. That is something really interesting because that means that I will save all the keys in a trusted zone in the cell phone. So we will more complicated for a user can catch it. Just will have access to our users. And we have symmetric keys from the API 18, asymmetric keys since the API 23. And we have some zipper algorithms here. We can see the IAS and RAS zipper algorithms. And this is just a simple diagram. So now we have our plain data. We will choose an algorithm, and we will combine with a key or a pair of those keys, and we will create our zipper information. So this is a small example of how I can use the zipper for encrypt information. So I am sending a string data, I am sending a key, and with the zipper, I will encrypt this information, and I will catch information encrypted. And this is the way where I can unencrypt this information. So now we will talk about the security myth that a Starbucks user from defend his case. So they say it's better for mobile apps to be easy to use or secure. They were saying if I want a friendly user application, so that means that the cost is no security. If I want security, that means that I will have a no friendly user application, because they want to maintain a permanent open session. So what I have here is this. Everyone of you listening about OAuth before? Yes, someone say yes. So OAuth basically is a protocol or a standard that established how we will manage the authentication and authorization process in our applications. This standard started to be cooked in 2006. And for 2010, the guys have the first version, official version to the standard. And the issue of the Starbucks was in 2014. So that means that for that time existed a standard that established how we can manage a permanent open session. So what those guys have was a bad API design. And they needed to, in any request, you send a username and a password. Indeed, if you don't believe that, but this is really common. We saw around the world many REST APIs that are designed to, we need to send the username and the password in each request. So the guys is ejecting a login before they eject the other process in each request. So this is a security issue because you need to save the username and the password in your client side for don't make to do your users insert that username and password always that they will request something. So the OAuth established some steps before. We will have a client app. We are having now an actor that is the OAuth server that can be in the same server to our resource servers. So the client app will request a token to the OAuth server when they may login. So I send my username and my password to the OAuth server. The OAuth server will validate this. This is the authentication of the client, and we generate a token. A token can be wherever that you want it. OAuth don't establish that you need to use some protocol or nothing. You can generate the token that you want. If you want that be a hash with the username and the password, can be indeed when it's not the best. And you will return this token to the client app, and now the client app will save this token for sending each request to the resource server or a REST API. So now to the client app has this token saved. When he wants to request something, we send this token for identify himself. And the resource server will connect to the OAuth server for validate that token. And the OAuth server will return to the resource server, you know, this is a valid token, or is not a valid token, or is a valid token, but this user don't have access to the things that he wants to access. And then the resource server will connect to the client app for say, you know, your session is expired, or we cannot provide you this information, or take that. So they could use that. And now we will talk about JSON Web Tokens. Who of you listening about before JSON Web Tokens? JWT, someone guys? Okay, good. So JWT are a new standard that is starting in 2014, by the way, and established, well, it's a collaboration for sending a JSON in an encrypted way. And with JWT are other ones, like JWS, JWKeys, and JWE for encryption. So a JWT looks like that. We will have a header, and we will have some claims. And in the header, well, we will save the algorithm that we use it for encrypt this token, and we have all the JSON with the information that we want transform, that is transport, that are the claims. What happened with the JSON Web Tokens is that anyone can have this token and see what contains the token. So we can combine, well, we combine it with a JSON Web Signature, so that is an extra thing that we are adding there. This is for guarantee that if someone takes the token and modify the information when came to our backend, we will verify if the signature corresponds for the information that is being sent in the JWT. So if that don't match, we will say this is not a valid token. So this is all the algorithms that we have with JWS. So we have the HS, the RS, and the ES. And we have the algorithms that we can use here. So now we will have a token with three parts, a header, a claims, and a signature. This is how it looks unencrypted. So we will have that part to the header when I have the algorithm and the type of token that I am generated. I am here my claims. So exist some specific claims that were defined for JWT, and exist others that we can create it. And we have here the signature. So anyone have access to the signature. Something that happened with JWT is that only the backend side has the key that was generated these tokens. The client side never has this key, because the objective is the client only save the token and send it to the backend part, always that we will request something. So happens something with this claim that we have in the header, that is the type JWT. So since in Android we can program in with Java or Kotlin, and we can choose many libraries, and our backends can be developed in any other programming language. So we have a lot of choices of libraries for implement JWTs. So what happened with this is that some libraries just exclude this claim, because it's obviously that we are sending a JWT, and that becomes in a problem if you are managing many programming language in your team, because one libraries will require to you that have this one and others don't. So you need to choose one that be compatible with all them, or you can indicate that ignore this or put them. So this is other interesting scopes. Right now, well, in the past, we manage user roles, but now usually we have roles or users that have dynamic permissions in our systems. So scopes are designed for we can put which permission and what kind of permission we have over this action. So we have the repo, and he only can read information. We have the GIS, and they can write information in this one. And this is some registered claims, so are claims that are defined for we use it. And we have two that are the more common users, that is the sub, that is the subject of the token. So in the sub, we are defining who is the person of the username, the user that defined this token. So don't put the username. Anyone can have strategies. You can put a hash to the ID in the table. You can create a username, a nickname, or something. And the other one is this of X, that is for expiration in a numeric value. Sometimes we don't need to have an open or permanent open session like the guys of Starbucks. For example, banks cannot permit to some guy have a open session all the time in the application. So it's a security box. So here I can define to that token only have 1 minute or 5 minutes of a validation of life. And when that token arrives to the server will validate to this expiration time was not ended. If the expiration time pass, we will require to the user that make a login again. So with JWT, we can solve many problems. One of them is authentication authorization. We can create federated identity. We can make in-depth information exchange between two parts. We can manage to the client-side session. This is an stateless, is that they are not saving an state. So that works for anyone can modify the cookies in my system, for example, or for have client-side secrets. But in this case, we are talking about JWT in the way to solve authentication and authorization process. So returning to these diagrams to like OAuth, we will have the client that we will make a login to the server. The server will generate a JWT as the secret or the token and will return to the client, and the client will save this secret, this JWT, and we'll send this JWT in the authorization header or each request after the login, and the server will validate this JWT and will respond to the client in base of that. So this is the authentication process, and this is the authorization process. Exist people that confuse those two ones. And if you want to read more about JWT, is this website that is jwt.io, or you can download this handbook that have more information for how to use JWTs, not only for authentication or authorization, if not for implement federated identities or other situations. So now we will talk about failed encryption. This is other of the problems that we have. Exist institutions like the financial institutions that are really paranoid about the security of the information. So sometimes for there, it's not enough use a SSL or TLS certification. So they need that we encrypt the JSONs that are traveling there. So what happened here? This is a real case. We have a bank, right? And we have a account name, account number, and much information. And the people say, we don't want to send this JSON in plain text in that when we are using HTTPS. So we say, okay, we can make an implementation and encryption, and we can set the JSON like that one. So came one guy of the bank that those guys that believe are genius and say, no, we will make that. Yeah, someone laughed now. So what happened with that? So what could go wrong in that context? Well, result that we have the unencrypted and the encrypted information. And exists something that is called reverse engineering. If you work in security, making encryptions, blah, 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 and using algorithms, you can notice in one moment that to the encryption algorithms have a pattern. So if you see many things encrypted, you can say maybe they use RSA encryption or IAS encryption. And you have the two values. So that means that you can test these algorithms with the value for found, the secret key, and the encryption algorithm. And now we need to think that we have a really powerful computer power for make those things. I can put some powerful servers for run force brute things based in the params that I am watching that. So, but how do you send someone that believes a genius that is making that wrong? So you can suggest other more hard things, and these same standards have the JSON Web Encryption. That is a more complicated way to send information encrypted. These ones, in the opposite to the JWTs, you cannot take them and put in some way and see what they have inside, only the header. So these have 5 parts, that is the protected header. They have an encrypted key, initialization vector, a ciphertext, and authentication tag. And they have a mathematical core for make the encryption. So you will see something like that. This is, for example, a simple example of this protection header that just established an algorithm and an encoding but we can define this mathematical curve for make the encryption more complicated. So we will don't talk much about them because they don't have much time, and now we will continue with other things. now talk about the problem with the user credential to our users, right? This is something that really happens, right? That mean, you know, in my home, I have internet, and I have this router, and I know where is the password. Everyone can find that. And supposedly has a password for we as user don't make any configuration there, but you can do that. So what happened right now is that we are providing systems that only implement the single signing on. And the problem with the single signing on is that with all these hackings that is happening in the world, anyone have access to the password of users. And so it's impossible to have different passwords in so many places that we need to make login in nowadays. So usually users use the same password for everything. So I hate my bank that asks me change my password every 3 months. It's like saying, no, damn it, why a new password? And I cannot repeat passwords. It's like, right. This is hard, so people use the same password. So if some hacker found one password in one system, can try in other systems the same credentials. It's simple like that. So what is to the people made for fix that? So we will create rules for force users to create better password and strongest passwords. And happen things like that. I don't know if you in the back can read, but here said, okay, what's that? You want a upper letter. So okay, there's one uppercase letter. So they say, what's that now? A number, very well. Now what? A special character. What's that? Finally, password 123 with acclamation. Super secure password, right? This is not super secure, but match with the new rules. And then happen websites that have things that I call the password nightmare. Is that? Yeah? And then when we try to make login in those websites, happen things like that one. I don't know if you read, but say enter your password, wrong password, okay, reset password. Enter your new password, and they came and say to you, your new password cannot be your old password. I hate those guys, you know? In that I will not say which company, but I have a website that always is the same. So I don't try to enter the password. I always go direct to reset password and put my email, because always is this same history. So this is a problem, and we need to improve our authentication process. So we don't need to put more rules and make the way to use passwords to our users. So how we can improve the authentication process? So first, exists technologies establish that we need to require to the user make access with something that they know, that usually is this single signing on. And then they can combine it with something that they have or a biometric process. So where is that? So they will make the login. But in addition, they will need to introduce something that they have, that is those tokens, for example, or the biometric part, this application that have for the pictures. This is complicated because sometimes people just, you can put a picture to other one. But exist libraries that force you to make like that or move the face, or use the fingerprint. And this is something that rise and come in the multi-factor authentication, so or two-step authentication. It's more common see it used with the SMS codes. Something that happened with the SMS codes is that when we travel, we not always have access to receive SMS codes. So cannot make login in other parts of the world. But it's really commonly used, for example, in Google. The 2 steps is used with SMS. Other thing is, this is an application that is called Guardian. And in this case, the guy is making login in a website. So then they have an application, and you can come and scan this code with your cell phone. So they say, okay, we scanned that code, but then you need to come to the app again and really allow permissions to this website for mail login. And then we are inside. So it's something that we can use just with internet. It's a little bit more complicated. It's more secure in that we can avoid the fact to have a password. So the guy just will enter their email address, and then we'll use the application. So then we have the federated identity. Someone here listening before the name of Federated Identities? Yes? One guy say yes. I know that all of you use sometime Federated Identity, but didn't know that the name was Federated Identity. This is not anymore that make login with third-party application like Facebook. So what happened in the past? Why what means Federated Identity? So in the beginning of the internet, we have, for example, different domains, but just the domain that create information and context in a browser cookies storage have access to these cookies. So I will put this in terms of Facebook. I don't know if you are reading the app names that have the Facebook in Google Play, the package names, the scum.facebook.orca, Katana. Anyone read that? Yes. Katana is the Facebook application, and Orca is the messenger application. So they have two different domains, for example. So imagine that domain 1 is Katana and domain 2 is Orca. So in the past, I came to Katana and made login and I can watch everything. But if I want to chat, I need to go to Orca. But that will require to me make again login. They will don't detect that I made login before in Katana, in that one is the same. And this is because the internet have restrictions to Orca to access the things that Katana created in the storage. So they say we need to create a strategy that provides to us the way to these two different domains, Katana and Orca, that as for the same product, have access to this same cookies storage. So they created a federated identity. It's a way to provide to two different domains that are from the same company and related with the same content have access to this same information. So this is when born the identity provider or the servers for provider. So now the consumer of the client and the server will connect to this identity for have access to this information. And becoming this more crazy, right? We will now have an authentication server that we will add through domain, and Katana and Orca will communicate to this server for make the login, and is this third-party server the one that will storage things in the cookies. So if I make login in Katana, I don't need to make login again in Orca, because I made previously login. So how many of you make registers and login in applications using Facebook as users? You know, I say, oh my God, thanks God, these guys have Facebook register. I don't need to create a new account. I don't need to create a new password and stay remember them. How many of you implement Facebook in your applications? Yeah, how many of you want credit for do that? All of it, yeah, exactly. Implement Facebook as federated identity is a piece of shit and a crap. Yes. You know, sometimes the system is not working. It's full of the Facebook API. Yes. Okay. So this is what we know connect with other institutions. So then we have to the passwordless authentication. Who listening before about passwordless? Some guys. Okay, good. Passwordless really means that provide the user the chance to make login without password. And in some cases, indeed, I can provide to them the option to make a register without using a password. So we have here, this is one example. In this case, the user created previously a password. But they wanted, for example, to the users in a company, the employees have access to the system as fast as possible. So what they do is the user is accessing to the application using an IP of the company, they immediately will provide the access. So then they look to if the username is around a health fence. So that means that they are talking to about the fact our employees can have homework. So this will be only if they are in the office. So if they are using an IP access in the range and are in the office, they will access immediately. If not, they will require multifactor authentication for access. But then this is using the fingerprint. So cell phones have the option we can use the fingerprint, and this is an interesting diagram. So we will validate with a Touch ID. So we will see if this fingerprint exists in our system. If this fingerprint don't exist in our system, we will create a new user. If not, if the user exists, so we will create a JWT as the process of the login, and the guy will be logging. Then we have the SMS codes too. So the user will be enter the code. So previously we require to him the username. In this process is really interesting. You know, I don't know why sometimes financial institution, all financial institutions have so decentralization of their information. So I went to actualize my information, my cell phone number, my direction, blah, 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 but they never actualize my information for the mobile application and online bank. So I forgot my password because that change every 3 months. And I say, okay, I will recover in my password. And say, okay, I will send to you an SMS. And I say, okay, thank you. And when I say, we send to you a new password to this cell phone. And I say, fuck them, and I don't have this cell phone since 8 years ago. Yes. So when we implement those things is like Facebook made, so we will send to you a password to this email, and I asterisk, and show you the last 2 digits or a few digits. And the people need to fill the number, and we will validate if this phone number that they are introducing is the same, that we will save it. If not, we will send codes to other cell phones that are not. So in this case, we will obtain a code as password in an SMS, and we will introduce that in the application, and now we are entered there. The other one is the magic link, that is one of the most commons, and in that this can match with the part of the fingerprint that the people introduce an email address, and you say, okay, this user exists or not. If not, we will create the username, and in the magic link, I can verify to this user is a real one, and they have access. How many of you use Slack? Yeah, many of us. Slack is the master of the magic links, especially for cell phones. In the web, we need to introduce the username and the password. But they send to you an email, and this is the magic link, so I only make click, and I am in all the workshop that I can have in Slack. So now talk about identity management. So identity management stopped to be only just for manage users, right? We need to manage permissions and more information about users, not only a username and a password. So in Android, we have quite a few options, and the first one is the Firebase authentication options. How many of you, well, all of you listening about Firebase before, right? And Firebase authentication too, okay, good. So Firebase authentication have a few quite interesting things. I like a lot this of anonymous authentication. So if you believe that you are entered to an application and watching things and nobody is registered what things are you doing, I'm sorry, but this is happening. So they have anonymous authentication, so someone can start to using my app instead without any register or login. I will create anonymous user associated with this cell phone, and I can make register of all the things that they are doing. And then when the username finally make a register, I will associate all the things to this anonymous user to the new registration. The only thing is that they only can manage a name, an email, a photo URL, and a password. This is all the information that you can have about users. And we have the single signing on. We have passwordless with email link and phone numbers. And we have a multi-auth providers, federated identities for Google, Facebook, Twitter, and GitHub. So we have quite small options. But sometimes we need more options, sometimes. So this is other options, that is the people of Auth0, that in that Auth0 become in February of this year a Google Cloud partner for solve all this of identity management. So this is a quite of more extensible solution, more robust. We can have single signing on. We can manage log of login boxes or the website. You see that some websites, when you have inactivity time, they block it for you make the login again. We have a more powerful user management. We have the passwordless, multi-factor authentication, and breach and password detections. So with OAuth, we can manage and we can define all the information that we need about our users. Other thing is that we can choose if this information, we will save it fully encrypted in a database of Auth0, or I can choose if that will be saved in one of my databases. We can define roles. This is for dynamic permissions, and this is something that we can do for each user or define a more extensible roles. We have a more extensible federated identity and more complex passwordless, and the multi-factor authentication guardian, that is the video that I showed you before. So about the social federated identity, well, you can choose any of all those ones. They have enterprise federated identities. And this is other interesting. I never expected to see that banks have federated identities. But banks have federated identity. I saw the surprise face of many of you. But yes, so if someone wants access to these slides, are posted in this GitHub repository. This is my Twitter, and this is my Facebook. So are that 1746. But if someone wants to ask something or want to run to the funny talk, can do that. Thank you for coming.